Hello, everyone. Today is May 26, 2021. We are having a talk with the valuable author of the book For the Love of Physics, Professor Dr. Walter Levin, who taught physics with love to many students all around the world through his video lectures. And today, me, Associate Professor Dr. İlknur Guhan from Marmara University, Atatürk Education Faculty, Science Teaching Program, and my students who are taking my Physics 1 and Physics 2 course and who are science teacher candidates are very happy. My dear students, I forwarded all of the questions coming from you to Mr. Levin. However, he will be able to answer mostly 30 of them. We are recording this online conversation and we will share this video with you if you want. And we will share maybe later on YouTube. You can turn off your video cameras if you want to, and please turn off your microphones. And I am thanking to Mr. Levin for being with us today and giving the floor to him. Thank you. And the first two questions are from Gülşen Karacadağ and Sevdenur Yerişenoğlu.
Okay, I consider that as one question.
Okay.
The question is, was there a turning point in your life where you decided to make physics the focus of your life? And then the question is, how did you meet with physics? Well, my answer is going to be very, very disappointing for you. Because my choice to go into physics was a negative choice. I was quite good in physics, in math, and in chemistry. So I could have gone into physics, math, or chemistry. I couldn't think of myself of doing the rest of my life math. Not my nature. I have a very bad memory. And my perception of chemistry is that you have to memorize an enormous number of things. But physics is not about memory, it is about concepts. So my negative choice was I picked physics. Little did I know at the time that I was made for physics and that physics was made for me and that physics was in my blood. Next question.
This question is from Rana Firdevs Yilmaz.
How did you decide to write For the Love of Physics? My lectures at MIT 801, 802, and 803 were videotaped, 1999 till about 2003. When MIT OpenCourseWare opened up in 2002, my lectures were among the very first that went online. So anyone in the world could watch them through MIT OCW. And my lectures became very popular. We had already early on about 1 million views per year. And then Sarah Reimer from the New York Times on December 19, 2007, wrote an article about me on the front page of the New York Times with a picture of me on the front page of the New York Times. At 71, Professor is a pendulum and a web star. Can you see it?
Yes.
New York Times?
Yes, yes, we can see it.
Can you see my picture now?
Mm-hmm. Yes.
Can you see the text that I'm a web star?
Yeah, I can see, but I cannot read now.
Yeah?
Yes, wonderful.
Okay. Now imagine if you get your picture on the front page of the New York Times, you will get invitations from many publishers who want you to write a book. About 8 publishers wrote me. I finally decided on Simon and Schuster, and I also chose my co-author, Professor Warren Goldstein. My book has now been translated in 15 languages, including Turkish, and we have sold about 3,000 copies. Next question.
And these questions are from Betül Demirci and Yasemin Ercan.
What was it that prompted you to search for X-rays coming from stars? And what was your motivation to become a professor and being a lifelong learner? Well, I got my PhD in the Netherlands at the Technical University in 1965. That was in nuclear physics. I got an offer from MIT for a 2-year postdoc position. So you would go 2 years and then you go back to your home country. I went there to MIT in January 1966 with my entire family, my wife, and 3 kids. And I joined the group of Professor Bruno Rossi, who was one of the co-discoverers of X-ray astronomy. It had been discovered in 1962 with the famous paper by Giacconi, Rossi, and Paolini. This was a gold mine for me because I joined so early. I joined 3 years after the discovery. I was promoted already in June 66 to become an assistant professor. You can imagine I never went back to the Netherlands. I stayed at MIT. I became one of the pioneers in X-ray astronomy. In my 43 years at MIT, I have written and co-authored 435 articles in referees journals, mostly about neutron stars, binary X-ray sources, black holes. I wrote 3 books on X-ray astronomy together with 3 astrophysicists in Amsterdam. In 2002, Riccardo Giacconi received the Nobel Prize for this original discovery. Next question.
These questions are from Saniye Uvacıklı, Yağmur Aykul, and Tuğba Kayış.
What are your thoughts on black holes? What is some evidence that they exist? And what is at the end of them? Sir, is there any development in physics that has excited you lately? What happens when 2 black holes collide? The evidence that black holes exist is not only 100%, but is 101%. The first strong indication of the existence was a black hole was published in 1972. There was a very well-known X-ray source called Cygnus X1, and in 1972, it was discovered by 3 people that Cygnus X1 is really a binary star. That means 2 stars going around each other, and that one of those 2 stars was a black hole. The evidence was quite strong. Now we know that the black hole in Cygnus X1 was 15 times the mass of the sun. I cover this in one of my lectures in the playlist Astronomy and Astrophysics. It is the first lecture actually in that playlist. And the title is Pioneering Decade of X-ray Astronomy. We now know that about a dozen of those black hole binaries exist in our galaxy, but we know for sure that there must be at least 10 million and maybe a billion, but we won't be able to see them because we don't have enough sensitivity. When black holes collide, they form a new black hole. But what is more interesting, they produce gravitational waves which were predicted 100 years earlier by Einstein. They were detected in 2015 with the instrument which is called LIGO. And my friend and co-worker at MIT, Professor Ray Weiss, shared the Nobel Prize with Kip Thorne in 2017 for the discovery of the first gravitational waves. It's one of the most promising fields for the near future. Next question.
This question is from Zeynep Kambur.
What do you think about life in other planets and galaxies? Well, there are more than 100 billion stars in our galaxy, and there are more than 100 billion galaxies in our universe. So roughly, there should be about 10 to the 23 planets in our universe. Even if the probability of life on a planet were as small as 1 in 10 to the 11, it's probably higher, then there would still be 10 to the 12 planets with forms of life. I hope this answers your question.
Thank you.
Next question, please.
Okay. And this question is from Simge Ersan.
What do you think about the reason why your lessons are so appreciated and you are so popular? Well, watch my lectures, and then you can tell me why. Next question.
These questions are from Beyza Demir, Kaan Köstek, Aleyna Çoban.
What is the most prominent factor in pushing you to study physics? Why did you concentrate on physics and not on other branches? What is the mystery that seems intriguing to you and why? Now, look around you. Turn your head, look around you. Everything is physics. Without electricity, your heart would not beat. You couldn't see, you couldn't hear, you couldn't walk, you couldn't smile, you couldn't laugh, you couldn't cry, you couldn't eat, and you couldn't drink, and you couldn't think. I know that some of you cannot think even with electricity, but none of you are in my audience.
Yes, sure.
Without electricity, there would be no cars, no trains, no planes, no rockets, no electric light, no radio, no TV, no GPS, no internet, no computers, no iPhones. Not even live sessions with Walter Lewin.
Thank you.
Now listen to this. All of chemistry is physics. What more reason is there to study physics? Next question.
This question is from İrem Poyraz.
Do you think time travel is possible? The answer is yes, absolutely, but you can only travel in the future. I advise that you Google twin paradox. The fact that you can travel into the future is due to one of Einstein's theories of special relativity. Let's discuss the twin paradox. You leave Earth in the year 2000 and you go with very high speed, but your twin sister stays on Earth. You return to Earth after 20 years. You have clocks on board and you know when 20 years have passed for you. And you've aged 20 years. So for you, when you return to Earth, it is 2020. Now, because of Einstein, your clocks went 11 times slower than the clocks on Earth, and your heartbeats also went 11 times slower than the heartbeats of people on Earth. Therefore, the people on Earth, that is your sister, aged 220 years, while you only aged 20 years. So on Earth, when you go there, it is 22,220. So your sister is dead, her children are dead, all her grandchildren are dead. So you see the future, but you can only see the future. Don't think this is fantasy. Yeah. This has been proven, though not with people. Next question.
And this question is from Jakub Can.
What do you think about dark matter and dark energy, which is said to make up a large amount of the universe, and why don't we know that much about it? Normal matter, that is everything that you can see. Stars, planets, galaxies, people, plants, animals, water, air, they're all made of atoms and molecules. They only contain less than 5% of the total energy in our universe. Then there is dark matter, which contains about 27% of the energy in our universe. And then there is what we call dark energy, which contains about 68% of the energy in the universe. So we have no clue about 95% of the energy in the universe, which is the sum of the dark matter and the dark energy. It's embarrassing. Of course, it is a strong field, active field of research to figure out what dark matter is. We don't know. And to figure out what dark energy is, we don't know that either. But you can imagine how many people make it a strong program of their research, because Nobel Prizes are lurking in the distance, of course. Maybe one of you will get one.
Oh, we hope.
Next question.
This question is from Beyza Nur Aydın.
Do you need an inherent talent to be good at physics, or is it about working hard? Well, it's both, of course. But you must also love physics. You should go to bed with it, sleep with it, and wake up with it to become a good physicist. Next question.
This question is from Rabia Khan.
Have you always taught your lessons in an untraditional way to make it fun. How did this teaching style develop? Yes, it developed. For one thing, I never bore my students. I make them often sit on the edge of their seats. I can make them laugh. I can make them stop breathing. I can make them cry, and I can even make them wet their pants. I confront them wherever possible with their own world. Why are the skies blue? Why are there red sunsets? Why are there rainbows? Why are there halos and white clouds and glories? In addition, I make them see through the equations. Students are scared of equations. They think that physics is all about remembering equations. Absolutely not true. Physics is about concepts. Therefore, demonstrations, when you have covered the theory, helps enormously. I also do dangerous demos. They love them. They even think that I risk my life. I always try to think out of the box. Teaching is an art. Each of my 94 MIT course lectures, listen carefully, each of my 94 MIT course lectures took about 60 to 80 hours preparation. 60 to 80. That included 3 dry runs in empty classrooms for each lecture. Wonderful. I hope your teacher is not so stupid to do that too. Next question. Question from your teacher.
Yes.
But don't you pronounce her name?
My name is İlknur Güven.
What do you advise first to my students, to science teacher candidates, and to the science teachers all over the world? Okay. First, your students. Broaden your horizons. Knowledge always adds, it never subtracts. Now for the science teachers. Only teach if you love it, not just to make money. I could not teach physics even if I didn't get paid. Just like visual artists cannot not make art, even if they cannot sell. Next question.
This question is from Lara Öztosun.
What do you think of space travel? Do you think we will settle extraterrestrial colonies on other planets? Well, as far as our own solar system is concerned, yeah, Mars is certainly a possibility. However, if we go outside our solar system, then the closest stars, which may have suitable planets to support life as we know it, those stars are probably further away than several hundred light years from us. So even if you could travel with 10% of the speed of light, it would take you more than 1,000 years to get there. That's quite a logistic problem, don't you think so? At the very best, it's going to be very tough. Next question.
This question is from Numan Türkmen.
What was the most interesting or fascinating subject among physics subjects when you were a student? Well, in the 1960s, for me, nuclear physics was then the most interesting. That wouldn't be the most interesting today, but it was in those days. And so I did my PhD at the University in Delft in 1965. Yeah, that was for me the most important then. As I stress, it would not be the most important now. But I was very pleased to be able to do a PhD in nuclear physics. Next question.
This question is from Ayşe Şeyma Bayram.
Unlike other physicists, you try to make physics more accessible and understandable for all. Leonardo da Vinci tried to express himself with paintings and Beethoven with his works. Is physics also your way of expressing yourself? Yeah, of course. But I am not at their level. So you shouldn't compare me with them. Next question.
This question is from Didem Yiğit.
What is the price of living a life based on science and information in an age of increasing ignorance? Well, no price at all for me. It's even more reason for me to broaden their horizons and to lower their ignorance. Next question.
This question is from Ertuğ Bera Doğan.
Oh my God. I'm so happy you pronounced that name. I could never have pronounced it. What is an unusual moment with your students that stands out that you can't forget? Good question. The MIT Muses sang for me on May 13, 2008, during my last 802 lecture. They had composed a wonderful text, especially for me. You can view it on my channel. It is in the playlist 17th century. No, it is the 17th century in my playlist short videos. So you go to the playlist, you look under short videos, and it is the 17th lecture there. And the title is The MIT Muses. It's wonderful. You will love it. Okay. They stole my heart, all these women. Next question.
This question is from Gamze Koç.
How have you kept your love for physics alive all these years? What do you advise for young physicists to do the same? Well, it's very easy for me because physics is my life. I love it. And I radiate my love for physics. It's contagious. My advice to young physicists is do not teach physics unless you love it, as the chances are that you will become boring. Next question.
This question is from İsmail Hakkı Acar.
What is your opinion on artificial intelligence? And do you think it's good or bad for humanity? Great question. All advances made in the medical area, in physics, in chemistry, had very positive effects, positive on our economy and on the quality of our lives. And frankly speaking, that's why I'm still alive. But all can be used and all were used for terrible destruction. Gunpowder was invented in 850 AD by the Chinese. At that time, it was a driving force behind technology, but it has been used destructively in every war. Nuclear energy, which we owe to Einstein, E equals mc squared, was an energy saver to the world. Today, about 30% of the world energy is nuclear energy. E equals mc squared. But E equals mc squared is also nuclear bombs, which sooner or later will probably destroy the Earth. Cyclone B is used for delousing, closing, and for fumigating ships, warehouses, and trains. But it was used by the Nazis in gas chambers to murder several million people, including my grandparents. Opiates are a type of narcotic pain medication, extremely useful. But opiate addiction kills about 50,000 people every year. No doubt artificial intelligence will have its good sides and its bad sides. It's too early for me now to judge. Next question.
This question is from Ruken Kol.
You talked about nuclear fission. How can different elements turn into gold? Yeah, it was the dream in the 16th century to make gold, remember? Even Newton tried it. All right. The number of protons in a nucleus determines what the element is. Hydrogen, 1 proton, helium, 2 protons, lithium, 3 protons, carbon, 6 protons, gold, 79 protons. In the periodic system, we write gold, 2 letters, capital A, lowercase u. The number of neutrons in a nucleus can vary, and we call those isotopes. So there are 21 gold isotopes, but each of them must have 79 protons, otherwise it wouldn't be gold. The minimum number of neutrons that can be in a gold nucleus is 90, and the maximum is 127. Only one with 118 neutrons is stable. All others are radioactive, and they decay into other elements, not into gold. So how now can you create stable gold? We call that gold 197. We give that a name, a number. 197 is the sum of neutrons and protons. Remember, 118 neutrons and 79 protons, that makes it 197. So only gold 197 is stable. How do you make that? Well, you can use a synchrotron, cyclotron, and you can shoot 1 proton in the nucleus of platinum 196. Platinum has 1 proton less than gold. So if you shoot 1 proton in platinum 196, it becomes gold. And it becomes gold 197. So that's stable. So you can turn stable platinum 196 into stable gold 197. However, to pay for that with the cyclotron, to even get 1 milligram may cost you more than $1,000. So you're better off to buy gold in the stores. Apart from the fact that platinum is probably more expensive than gold. Next question.
This question is from Öykü Mankalye.
Sir, you inspire a lot of people in the world. What are the things that affect and inspire you in your life? Physics is my life. Art is my love. Pioneering physics and pioneering art are both new ways of seeing. And in some way, I believe that my lectures are also a new way of seeing. Read chapter 15 of my book, For the Love of Physics. Here it is. In chapter 15, I discuss in great detail the new way of seeing. That's what's important in life. Pioneering. Pioneering art, pioneering physics. Next question.
Okay.
By the way, could you see my book?
Yeah, we saw your book.
Could you see it, or shall I show it again?
Yeah. We saw it. Yes.
Okay.
We have also our books.
Next question.
Okay. This question is from Büşra Tashkrant.
What is the experiment you most enjoy performing? Question. Well, it's not just one experiment. What I love to do, one of my favorite, is I create a rainbow in class using one drop of water. And with that one drop of water, I explain the color sequence of the primary bow, the secondary bow. I predict by telling them everything about the rainbow that the light of the rainbow must be polarized. And with that one drop of water, I demonstrate that the rainbow that they see is indeed polarized. That's one of the reasons why I always carry on me a linear polarizer. And all my students at MIT, all of them in my classes, I always gave them a linear polarizer. So at the very least, when they saw a rainbow, they could test that indeed the rainbow is linearly polarized. Apart from that, the blue sky at 90 degrees from the sun is also 100% polarized. So they can use that same linear polarizer to look at the sky 90 degrees from the sun. They rotate their linear polarizer and they can make the sky completely black there. I also demonstrate in class why skies are blue. I do that with cigarette smoke. I love to swing from a pendulum and to show them, which is very non-intuitive, that the period of a pendulum is independent to the mass that is hanging on the pendulum. And to make sure that they never forget that in their lives, I first swing a pendulum with 15 kilograms at the end. Then I sit on the 15 kilograms and I swing with the pendulum and I show that within 1/100th of a second, the period of Waterlooing swimming is the same as the 15 kilograms swinging. Quite impressive. I'm sure all of you have seen that. It's almost my icon, swinging on the pendulum. By the way, you see, it's almost my icon.
Yes.
Here's the pendulum in the cover of my book.
Yes.
I also like one of the demonstrations where I generate inside a closed box sound, and I make the students listen to the enormous number of resonance frequencies that are caused by the shape of the box. Very impressive demo. I do that in 803. And then maybe one of my most favorites is to show Heisenberg's uncertainty principle. There's only one way, I believe, that you can demonstrate in our life a quantum mechanical effect, Heisenberg's uncertainty principle. I even believe, but I am not sure, that I was the first to ever do the experiment that way and quantitatively proved that Heisenberg uncertainty principle was behind it. I use laser light and I shine that through a very narrow slit, which I can change in size. And the smaller I make it, the larger will be the light that comes out of the slit. And that's what Heisenberg's uncertainty principle predict. I discussed that in one of my lectures, which I gave for NHK TV in Japan. The playlist is called 1 Hour Talks for NHK TV in Japan. It's one of my 8 lectures. It's very interesting. You may want to see it. It may be the only and the last time you see in your life that Heisenberg's uncertainty principle is for real. It is lecture number 7 in that NHK TV playlist. Lecture number 7. Next question.
This question is from Lara Erbilgin.
If you invented something brilliant for science, but that could be used to harm humanity, would you share it with the world? Well, I refer to my answer about the fact that almost all good things can almost always be used in a bad way. However, if what I invented could only harm humanity, I would not publish it. Last question, Ignor.
Okay. And our last question is from Tuğçe Sartas.
How do we perceive the fourth dimension? What are some false notions about this? Well, the answer is simple. We cannot perceive the fourth dimension, period. However, in terms of math and physics, we can work with many dimensions. Einstein's theories have 4 dimensions, 3 of space and 1 of time. String theory has 15 dimensions, 1-5. So as far as theories is concerned, and these theories can be verified, any number of dimensions is allowed, and that can be verified observationally. Ignor, I think we've come to the end. And how long has it lasted? 40 minutes.
Yeah, it's very...
No, 43 minutes. Did I tell you it would last 40 minutes?
Yes, exactly the same what you told me before.
By the way, I would like to put the video on my YouTube channel.
Okay.
Yeah.
Okay.
So when you have the